Hello everyone, welcome back to this Beckhoff TwinCAT 3 motion control series video. And in this video, we will mainly talk about MC home. I will introduce two methods for homing the axis. One is MC direct, that directly set a zero or sets a predefined position to the axis. The second homing method, that is the homing sequence, basically especially used for the incremental encoder. After we shut down the power, recycle power of the machine, the incremental encoder will lose the value. Basically, the value will be zero. But maybe your tooling or your motion system is stopped at some place. So that place, maybe 100 millimeter or some value else, is not a zero position or some defined position. So after the cycle power, after the incremental encoder lost the value, we do need a sequence to allow this system find the home position. Basically, we will allow this system go back to a home sensor, allow this motion slowly moving towards to the home sensor, and then once it's touched the home sensor, do a simple sequence. Regarding this home sequence, basically, we will let the system moving backward, go reverse moving towards to the home sensor. Once the machine touches the home sensor, and then it will slow down, and then leave out of this home sensor and set the zero or find the encoder Z mark and give a direct zero or preset value to the axis. That is the home sequence. The machine will go back to the home sensor position, find out the home. In terms of this homing topic, there are a couple pages I highly recommend. Firstly, go back to Beckhoff information system, find out this hierarchy, TwinCAT 3. TF 5000 motion, and find out this axis encoder homing, and you need to read detailedly for this page. For homing method, there are a couple methods here. Basically, when we use the direct homing, use the program direct set a home position value from our axis. For this calibration value here, we will select default and let the function block set direct zero or predefined value to the axis. If we are using the home sensor, especially other than the home sensor, we also involve the zero mark or C mark or Z mark from the incremental encoder. We will use the hardware synchronize. For some simple application, we use home sensor only without the zero mark. We could use the Plc CAM. The CAM here means from the Beckhoff, it means the home sensor. Okay, so I will firstly talk about this default using the function block direct set home. And other than this page, the MC home, this function block is still important. So you can go to the motion, find out the MC2, find out the homing MC home. From this MC home, especially for this home mode, so there are a couple settings here. We can select MC underscore default homing, MC direct, MC force calibration, and MC underscore and MC reset calibration. Basically, from my experience, we will mainly select the MC underscore direct. That allows us to direct set a value to the axis. Meantime, the axis configuration, we will select the default. And if we try to run the homing sequence, we will select MC underscore default homing. The default means some direction moving and finding home sensor speed, we will rely on the axis configuration. I will explain this after. And other than this, highly recommend you read the detail for this sequence. Basically, for this diagram, it shows once we trigger the homing sequence, this typical scenario shows the motion will move backwards towards to the home sensor. And once it's got the home sensor, it will stop and go reverse, find out the zero mark of the encoder, and then set a home to the axis, and then stop again. So basically, it will run this curve. I will use the measurement curve shows this process also. For the homing state, you can click this link and find out here the homing state. And from this defined 0 to 6, that associated with the number showing on that diagram. From the step 3, that waiting for the axis stop, because while that time the axis is finding home, go backward finding the home sensor. Once it touches the home sensor, the motion will leave out of the home sensor, got the falling edge, and then it will run backward, find out the 0 mark of the incremental encoder. So this is the state from that diagram. Okay, that is this diagram. Alright, let's firstly talk about the direct home. This is very simple. This is my MC project. I will use this MC home to reveal the programming and the hardware setup. You better review a couple videos before. So I pasted all the links from this playlist. You can review those videos. We will directly talk about the MC home. So firstly, we will talk about MC direct. Okay, so now let's power up the access. In the meantime, as a previous video I showed from this window, watch 1, so we can drag the actual position and actual velocity. So like now, so I just power up the system. My system, I'm using KL2541. This is step motor with an incremental encoder. And once I power up, enable the access. Now I can enable the access. Give a 100%. Okay. And now we can see after I power up without doing anything, this access gives me a value. Because this is the incremental encoder, so it just gives me an arbitrary value or some value else. So sometimes it also gives me a 0, okay? But this is not correct value. So I need to preset a value or direct set a 0. For example, at here, from this MC underscore home, here, I can set a pre-configured position. For example, now I set a 0. And from this homing mode, I roll this MC underscore direct. Roll this mode. This mode represents 4 at here. Okay, and once we execute this, we will see this 0 will directly right into this axis, and this actual position value will directly overrode by this value 0. Okay, now if I trigger, so we will see it rolled 0. Okay. Or if I preset 200 millimeter, and now if I trigger, we can see it overrides this value directed right to 200. Maybe that time after I write this value, the motion adjusts itself slightly, so we can see this small value at here. It doesn't matter. Okay, so this MC Direct is especially used for one application. For example, like this case, if our drive or motion system is driving a belt, moving this pallet towards to the tooling, and tooling will go up and down. Definitely, when this pallet stop at here, it need to line up with the tool. So that means whatever the belt, that position it is, so we are care about if this pallet and this tooling can be lined up properly. Right? So if the belt lose position and we send this pallets, if they are not lined up, this tooling come down, it will crash there. And in another scenario, if we are using the absolute encoder, at the very beginning, we need to precise this absolute position. We need to precise this absolute encoder. Or some cases, some incremental encoder, it has a battery behind. It can retain the value. For those cases, that encoder can save the value, but it do need the first initial value at the beginning. So this MC Direct can use for these cases. For example, I can jog move this pallet, just a jog move, or even use a hand manually move this pallet here, release the brake, motor brake, right? And then line up this tool and this pallet. And at that time, I can direct the right value, for example, 0 or 200 or 800. Maybe that this position, that's 0. So travel to here, that represent 200. So once I line up this position, I can directly write 200, this value, to the axis. Once I lose the power, it doesn't matter because the battery can save the position value. The position value can be saved, can be retained from the encoder, or the absolute encoder represent the actual position. So this home, the position can still saved, can still retained from this axis. Okay, this is a MC Direct. It's very simple, it's quite straightforward. Also, quickly review, if you are testing the system very beginning, you haven't set up the MC Home, in the Beckhoff system, it still allows you to set directly the value to the axis. For example, you can go to the axis here and go online and find out these functions. And from here, you can set an actual position value. You can set a 0 or set a certain value. For example, now I can set 100. So let's watch this value change. I can click this set, and then I can directly write the 100 value to the axis. And this axis value will stay here. Okay, this is MC Direct. Directly write the value to the axis. And then let's talk about this homing sequence. This homing sequence is especially used for the incremental encoder, especially for the case after we cycle power the machine, the incremental encoder will lost value and our axis will lost value. So after the cycle power, we do need a sequence to allow this machine or allow this motion system go back to its home position. Keep in mind, the home doesn't mean the 0, but most of the cases that is 0. But you can preset 100, 200 or some values that is the home position, or we can call that start position, right? We do need a procedure to let the incremental encoder to know what the actual position it stays. So we need this sequence. For this sequence, the MC function block can automatically run this sequence. But to run this sequence, we do need some configuration in the axis configuration. Also, we need to change the homing mode. All right, let me show how can we do that. Let me log out. So from this homing mode, let me change to the MC underscore default homing. Okay, change to MC underscore default homing. The default means we will configure something from this axis. And other than this, where is the homing sensor? We do need a hardware sensor to allow this MC home, this function know this is the home sensor, it turn on or turn off. So that homing sensor input of this MC underscore home, that is this, bool calibration cam. And at here, I declared one variable. That variable I named as a single axis underscore home cam input that come from here, GVL MC. So this is one global variable at here. And then I connect this home cam input, this global variable at here. So once this global variable turn on, this calibration cam signal of this MC home, it will turn on. So I need to declare one hardware input variable connect to this variable, and this variable can connect to here. Or I can directly use that IO, that variable connect to here. Now I can create one global variable list. Usually for the IO hardware interface, I will specially use one global variable page and name the IO here. Let me declare that is the home sensor. We add one prefix. So that means this is a bool and this is the input. Take care of this format and the syntax. So we declare one bool input home sensor, this variable defined as an input. So this format allows this variable after we build the solution, allows us to connect this variable to the hardware. In my case, I have one terminal named KL1408. That is the 8-channel input. I will connect to the first channel. But now I cannot connect that because I haven't built up that. So let's build the solution. So the system will generate this variable. And now if I go to this terminal, this channel 1 input, and from this variable here, click this link 2. So the system will pop up this selection, will allow us to connect to this variable. Okay, so this variable will connect to the hardware. We set up this bridge, connect the hardware to this B input home sensor. Okay, and from the program wise, if we go to this home MC home here, So at the very beginning here, we can set up very simple logic to read that home sensor from the hardware to this this variable. Okay? So at here, the first line, go to the toolbox, we will use one contact and use one coil. Okay? And we will use the IO home sensor. Okay, read the IO home sensor and we will transfer this home sensor signal to our internal variable. That internal variable, we will use this, a home CAM input. Okay. All right, so we transfer this signal here. And now our MC home, so we have a home sensor input now. And we change this mode default homing. So now what does it mean of this default homing? All the configuration, we need to go to the access configuration. Go to access. Firstly, let's go to the encoder. So find out the homing here. Firstly, we need to clarify that direction. So basically, the home position or home sensor will be located at the start position. And all the tooling or motion system will travel to the positive direction. That means when we search the home sensor, that direction will go to the backward, go to the reversed position. So that means for this invert direction for the calibration cam search, we will select true. True means we will run the invert direction. We will run the backward direction towards to the home sensor. That's the reverse of our normal travel direction, right? And after the motion touch the home sensor, if we are using the Z mark or C mark of the incremental encoder, after we touch the home sensor, the motion will still go to travel, find out the 0 mark from the encoder. And this additional travel direction we can define. We can still follow the backward direction or go to the positive direction. For most of the cases, we will use the positive motion direction. So for this invert, we will select false. Keep in mind, this is invert. So most of the cases, we will select this. That means searching the home sensor, we will go backward. But after we search the home sensor, the motion will travel to the positive direction, find out the 0 mark of the incremental encoder. I will show this case after using my step motor and the incremental encoder. Okay? Keep in mind, this is 90% cases we will select as this way, true and false. And calibration value, that means once we calibrate this value, what the actual value we can set. For example, most of cases we will set 0, but some cases we can directly set a predefined value, for example, 100 or 200. In this case, I will set 0. Okay, most of the cases will set 0, especially using this home sequence. And this reference mode here is very important. If we are using the home sensor and also we are using the 0 mark of the incremental encoder, we will select this hardware synchronize. That will allow our system finding the home very accurately because the 0 mark of the encoder just one resolution, one pulse. We firstly find the home sensor and then we find this 0 mark, the incremental encoder additionally. So this hardware synchronize will allow this home position can be set very accurately. If you are using one incremental encoder without the 0 mark, some cases your incremental encoder only have a and B, doesn't have a C or Z, right? So probably you can select this Plc CAM. That means we'll run the home sensor only without using the 0 mark. So you can select this. In my case, I will select this hardware synchronize because my incremental encoder has a 0 mark that can run very accurately. And this is a little bit more complicated scenario. You can see that time when that homing sequence is running, it will touch the home sensor, go reverse, and travel a certain distance, find out the 0 mark. You can see this sequence after. Okay, so I will select as this way. And after this, we can save and build. So this is incremental encoder homing setting. This defines the direction and this is a reference mode. Other than this, let's go to the axis. We need to define the searching home speed. Go to parameter. I find out this manual motion and the homing here. Expand that so we can see. Explained here. Towards to the PLC CAM, that means that's the go backward direction we just said. When we run towards backward, this motion automatically searching the home sensor. That time what the speed it can run. So we can set 50. Okay? And after it touched the home sensor, as we said, it will go positive direction, find out that off that PLC sensor because the motion will leave out of this home sensor position, right? And find out the 0 mark position. So that time, what the speed for that? Usually we will set lower than this because the lower speed of this searching home, the accuracy we could be, right? So we can set 20. That is very slow speed. Okay, so we define this 50 and 20. So basically this is the finding home position speed. So if you record and go down of this page and review this sequence, so this speed, that's the 50. And after it's touched the home sensor and then go backward, that speed, that is the 20 we define. But the diagram showing here, this searching home, that's the positive velocity. And off that sensor, finding the 0 mark, that is the negative. That is just a reverse the direction of our case I'm showing, but a similar idea, right? So this is searching home, we define 50. And leave out of the sensor, finding that 0 mark, we defined 20 millimeter per second. All right, we set up here. So now if we review the program, this MC underscore default homing that represent, we will use the setting from this axis we just did. So now I will build the project and download hardware and also download the program. Okay, click the downstairs and we will download the hardware configuration. All right, now we download the hardware. So here, this red gear is running. Now let's download the program. Okay, so quickly review our hardware. And also, let's check out this home sensor and let's see if this home sensor is working properly. Okay, now I'm using this simple switch on and off. I'm connecting that switch to this first input terminal. It has an 8 channel. I'm connecting to the first channel. So if I turn it on, so we can see the first channel it turn on here. Will be used for this home sensor, this function block, that calibration CAM. Okay? So for our scenario, for example, if we defined the direction, the positive direction of the motor is this direction. And for this motor, this clockwise, that's the positive. And for the travel, I will define this direction, that's the positive. So if you recall, that searching home, that is the backward. For example, this is our tooling. So backward means for some place else, when it's running this sequence, it will go backward direction because this is the positive. Go backward direction. And then it will touch this sensor. Okay? Touch this sensor. After it's touched the sensor, the MC home itself will trigger the motion run the positive release out of this home sensor. And then this certain distance will allow the system searching the Z mark. The Z mark that comes from the incremental encoder itself is the inside. The one revolution, just a 1-0 mark, that allows the system find the home or set the home that very accurately. Alright, so this sequence will run like this. From a positive direction, someplace it will run backward, search the home, touch the sensor, and then the system will automatically leave out of this home sensor and then find the search and then travel a certain distance. Once it's find the zero mark itself, it will slow down and stop. That time we can see that position will be a positive position, for example, very short, because once it finds the home, it will set a 0 or set a predefined value. But this motion definitely need a small distance to stop, to fully stop. So that's why after we run this sequence, we will find the axis is not a 0. It will travel, it will be a very small positive value. That positive value caused by from the 0 mark position to the stop, actual stop the position, which is fine. After stop, we can re-zero. We can use another MC function block to directly set a certain value. But this position, this stop date position can be very consistent. Okay, let me show this sequence. So firstly, I will dry run this motor. We will see this sequence. Okay, now I will trigger. Meantime, let me turn on this watch. As we can see now, this motion, the actual position shows 1300 someplace. It doesn't make sense. So we will trigger go back home. Okay, before we trigger that, we make sure our motor, let's reset everything. Reset the fault. This is basically the start procedure after we shut down the power, after we cycle power the machine, right? So after we reset everything, make sure motion, there's no any fault from the motion, and then we power on the motion and override speed. Okay, so we enable the motion first, and that time the value doesn't make sense. Maybe your tooling or maybe your pallet motion system is stopped at someplace else. And now we will execute this home sequence. And now I will trigger. Let's watch the motor. So after I trigger, we can see this motor run backward. That means this tool is towards to the backward direction, try to find the home sensor. Okay? And once it finds the home sensor, now if I press this home sensor, we can see it go backward, leave out of the sensor. Once it's go off, now the motor actually is searching the 0 mark from the incremental encoder. That now is travel back, go to the positive direction. It stop here. That means this position maybe just a little bit over travel because it definitely need to stop the deceleration that small distance. But that means the 0 mark of my incremental encoder, that basically is at this position. One revolution, the 0 mark is at here. So every time when I'm using the 0 mark to home this incremental encoder, that 0 mark always here. That's the physical position from this incremental encoder. Okay, let me do again. So after it's got home, we can see this value is 1.3 millimeter. That means after it find the 0 mark, it still travel 1.3 millimeter to stop this axis. So if you are considering this value at this stop position, you can set you can create another MC home, use MC underscore direct set a predefined value, which is fine. But this position is very accurate and consistent. We can write down this 1.318, this position millimeter. We can home this axis again, and let's see this position next time it set this axis. Okay, so now I will release, and let's assume I use the MC jog, move this axis someplace else. Okay, and now let's execute this home again. And meantime, I will use that small box to demonstrate that position, that procedure. Let me trigger. Keep in mind, now it's a positive place. And I will assume this home sensor is at a start position, almost near the home, almost near the 0 position. Okay, trigger. So now this step motor is traveling back. So that means this box is traveling backward towards to the home sensor. And once it's touched this home sensor, the step motor will travel back. You can see it's travel to the positive direction and leave out of this home sensor. After it leave out of this home sensor, it's still moving. That means the tooling, that means the motion is searching the zero mark from the incremental encoder. Okay, once it's got here, my incremental encoder zero mark is around here. Once it's got here, it stops. You can see it stops itself. This is that process. Okay, let's do again. So now I'm gonna release here, and let's travel to someplace else and stop there. And this time, let me change the speed. For example, if I go to the axis, and let's change the searching speed faster. For example, go to the axis, and this time for this searching home sensor speed, let's go faster. For example, side 100. And this off the PLC cam, that means let's go positive direction, leave out of that home sensor, that's a 20. I will prefer use this value. I will prefer set this value very low so it can find out the zero mark and stop the axis with a very slow speed. The slower speed, the more accurately we can get, right? So this searching home can be a faster, even for example, let's try 200. We can see the difference of them. Okay, let me download. Okay, now let's go to the program and this home. Okay, all right, let's run this home sequence again. So let me trigger this home execute, and this time we can see that searching home speed can be faster than before. Trigger. So this time we can see it's traveling faster. So that means it's going backward. So this motion is going backward, searching the home sensor. And once it's touched the home sensor, it will stop, and then it go forward, the positive direction, and then go to find out the zero mark inside. So this is a very slow speed travel forward the positive direction until it finds the zero mark from the incremental encoder. And don't forget, and if you record, the zero mark is at here. And once it finding the zero mark, it will set a 0 and stop. And after stop, it will over travel a little bit, 1 point something. Here, you can see it stop. So now we can see that position is set 1.3. Okay? So this is searching home. Okay, this is default homing, and we are using the home sensor as well as the zero mark from the incremental encoder. And if your incremental encoder doesn't have the zero mark, we can still use the PLC CAM, that method, without using the zero mark. For example, now I can release everything and I can travel somewhere else, prepare for the next time. Okay, and now let's go to the axis. So now let's go to the incremental encoder here. So we will switch this reference mode from the hardware synchronized to PLC CAM. That means we will not use the zero mark from the incremental encoder. We only rely on the home sensor. Once we select this PLC CAM, the system will use the falling edge of the home sensor to set the axis. Okay, so now I'm gonna download. So the system will use the PLC CAM only. Okay, and we'll still use this direction. And now let's go to the program. And we are at here. Let's run this MC home again. Trigger. And this time, let's watch this value change compared with the actual video. So once the home sensor got the falling edge from on to off, that short moment, we will set a 0 to the axis. So let me trigger this sequence. So now the axis is moving backward. It's going back, find the home sensor. And once it's touched the home sensor, it will stop. And once it's leave out of this home sensor, the axis will be set 0. Okay, let's do this again. So now I'm gonna move to someplace else. Okay, and alright, let me show this again. So now this position doesn't make sense in someplace else, right? So now I'm gonna trigger this home execute. We are using the home sensor only. So now I'm gonna trigger that. So we can see now the motion is running backward. That means it's trying to find out this home sensor. To show this clearly, I'm gonna use my finger, and keep in mind, so we will watch when the axis will be set 0. So now the motion touched the home sensor. Meantime, the axis still has a value. But once I release my finger, get this home sensor falling edge, we will see the axis will be set to a 0. But because that time the motion is still vibrating there, so now it's got 1.14, but it's still fine. That means the falling edge will set a value. The axis will automatically set a value, a 0 value or predefined value to the axis. This is the key idea. Okay, let's try it again. So for example, we can travel to a certain place. So this time is 1.14, right? So we can travel. Okay, so let's do this again. So trigger this searching home. So the axis will move backward, try to find the home sensor. And now if it touched the home sensor and then release the home sensor, and after that the axis will set a value. Now this time is 0.96. So we can see, compared with the 0 mark, that means this position, the set value will not be that very consistent, because the falling edge, once the system got a falling edge, maybe that time the motion still slightly moving. So that's why every time this position won't be very accurate. But depends, some cases maybe this accuracy, that's accurate enough for you. After all, without 0 mark, incremental encoder has been widely used, right? So it depends on your application and the accuracy requirements. Okay, that is the home sequence. So the key difference from the home sensor only or the home sensor plus the 0 mark, that is selection from this axis, from this incremental encoder, the selection here, that's this reference mode. Okay, these two selections. So from my experience, basically these two scenarios will cover 90% applications. If for the MC direct, you can select the default, and then from the program you can use the MC direct for this homing mode. Alright, basically this is 3 methods, or the main 2 methods, MC direct or the MC default homing. Default homing, we will cite the incremental encoder setting as well as the homing speed from this axis. Okay, alright, this is the homing procedure. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.